Hey everybody, in today's video I'm going to talk about compounded annual growth rates, what they are and how you can calculate them. So what a compounded annual growth rate effectively is it's a way to normalize a percent change over time. So for example, let's say an investment you had increased by 50% over a period of 10 years. It's hard to conceptualize whether that's good or not because you're looking at a 10-year period, right? A 50% gain in 1 year would be great, but over 10 years, how good is that? This is where compounded annual growth rate can come in handy because what you're doing is now you're doing a calculation to determine what that averages out or what it would be equivalent to if the stock just gained X percent every year. For instance, if it grew to 50%, that's the same as growing by a certain percentage every year. And that's a bit more helpful when you're doing comparisons as far as returns goes because, in the real world, we know that, an investment, could go up and then up higher and then dip a little. And so it's not going to be a straight line. But with the compounded annual growth rate, you can effectively normalize that and say, okay, it's the equivalent of this, right? And so what I'm going to do for this example is I'm going to go over a company's dividend history to show you how we can calculate compounded annual growth rate. The example I'm going to use is 3M. So 3M is pays a high dividend over 4%, and one of the great things about this stock is it regularly increases its dividend. You can see in prior years, it's always increased it. Back in 2009, it was only 51 cents per share every quarter that it was paying. Now it's up to $1.49. So it's a significant increase over those years. But how much does that actually average out to year over year? So let's do that right now. So I'm going to start by just calculating a simple growth percentage. So I'm going to take the dividend that 3M is paying today, so $1.49 per share, divide that by how much it was paying, let's say 5 years ago, in August of 2017. So go back to August 2017, it was paying $1.18, and I think that's actually rounded. But anyways, that's 26.8% that it's increased by over that period. And as far as years go, that was over a 5-year period. So to calculate the compound annual growth rate, we're going to use a formula. We're going to take this percentage of 1.26 and raise it to the power of 1 over 5. 1 over 5 being the inverse of 5, right? So we're effectively going backwards to work back those increases. And so that tells us the compounded annual growth rate was 4.86%. So if you wanted to do this in just one shot without any helper cells to do this, the formula would look like the current value, which again, put this in parentheses to make it easier, 1.49 divided by 1.18. So we've got the current value versus the previous, and then raise that to the power of 1 divided by the number of years, which is 5. So it's the exact same formula that I've done, but in this example here, I'm putting it all in one single formula in case you did want to know how to do this just in one cell. And so that gives us the same value of 1.048%. So let's prove this out now. So if I go back to August of 2017, the dividend was 1.175. So it's actually rounded here to 1.18. So 1.175. So let's say dividend is 1.175. And then after 1 year, after 2 years, after 3 years, after 4 years, after 5 years. So if we're going back in time, we're saying, okay, it was paying 1.175 5 years ago. And so let's say it grows at a rate of 4.8%. So what we can do is take this amount, multiply it by that compounded annual growth rate. Let's freeze that value because we're going to reuse this. And so it says after 1 year, so this 1.17 was 2018. So in 2019, if it was growing at that rate of 4.8%, it would have been 1.23. But this is 2017 and this is 2018. So in 2017 is 1.175. In 2018, the dividend was actually 1.36. So 3M increased it by more than this rate of 4.8%. Okay. Now let's look at 2019. So I'm going to hit Control D to copy this formula down. And now it's taken 1.23, multiplying it by this 4.8%. And so in year 2, if it increased at that rate, it would be 1.29. But in 2019, it was up to 1.44. So, 3M was increasing it at a much higher rate than just 4.8%. That's why there's this bit of a delta here that's been created. But it'll catch up because obviously it averages out to 4.8%. So in 2020, let's again copy this. Let's copy this formula down. And so based on that compound annual growth rate, we'd expect the dividend to be 1.35. But in 2020, it was 1.47. So still a bit higher than we would have expected using this compounded annual growth rate. Let's go to 2021. And again, let's copy this formula down once more. So 1.35 would increase by another 4.8%, and it would bring it to 1.42. In 2021, it was 1.48. So we see that gap starting to shrink a little bit because here it was a difference of about 6 cents, and 1.35 to 1.47 was a difference of 12 cents. So that difference has shrunk significantly. Here you can see the increase from 2019 to 2020 was 3 cents. But from 2020 to 2021, it was just a 1 cent increase. And the same thing happened in 2020, just another 1 cent increase. So if we look at 2022 and copy this down, again, 1.42 increases by another 4.8%, we get 1.49. Exactly what we've got here. So the difference being is, using a compounded annual growth rate, we're effectively saying, okay, the dividend, we're assuming it's going to increase by 4.8% every year. So it's going to be really linear, right? But in reality, look, we had an 18-cent increase followed by an 8-cent increase, a 3-cent increase, and 2 1-cent increases. So 3M started out at a high rate of increases, but then over time, it got smaller and smaller and smaller. And so that's why we have these sort of deltas between these years, between what we would have expected and what the reality was. And so if we look at the compounded annual growth rate, we can see that, okay, on 3M's average, a dividend increase of about 4.86%, putting that 26% increase into context. But even that can be a bit misleading because if we look at 1.49 divided by 1.48, the most recent increase was, less than a percentage point, right? It's 0.67%, right? So it's a really small increase. So it had high increases at the beginning, much smaller ones at the end, and it averaged out to 4.8%. So that's how the compounded annual growth rate can be helpful for you because it allows you to sort of see what it's averaged by, and taking those big increases and blending them in with the smaller ones to get to an average. And so this can be useful if, let's say, you wanted to forecast out what the dividend might look like in the next 5 years. You may look at the 4.8% and say, okay, maybe we want to use that as an average, but at the same time, you want to take into the context, the fact that this latest rate hike was just 1 cent. Right? So you sort of have to strike a balance as to whether you think the business is going to have some strong years like it did earlier, or if it's going to have some tighter years where the dividend increases are going to be much smaller. So you may want to, take an average of the 4.8% and, the less than 1% increase that it's had. So this is where the forecasting, it is going to involve some qualitative factors as to how the business is doing and where you think it's headed. But calculating that compounded annual growth rate can tell you how it's done over the past. And obviously, if you're looking at the past 10 years, that's going to be much different from the past 5 years, potentially. So just wanted to go over how you can calculate compounded annual growth rate, what it is, and how you could potentially use it for when you're doing your own forecasting.